What do you know? You got me again for another mini lesson. So, this week is not too much different from last week. We're going to recap on some things that we talked about last week because I kind of combined all technology. So last week was technology, and this week is technology and design. Woo! So I'm going to touch on a couple more things and kind of recap some of the things that we went over last week, and hopefully you guys will have this down pat. So yes, just a bit more technology. So last week I talked about this briefly, but in this week's lesson you're going to hear a lot about technological design. And you have to understand that the purpose of that's a hard word to say, technological design is to invent, build, and operate technology, and it's going to solve problems in an accurate and, most importantly, an efficient way. When you guys think about doing something efficient, isn't that the best thing ever? When you know that you are working on your schoolwork and you're efficient, you're actually using technological design because you're basically operating technology and you're going to solve problems, being that you're in school working on assignments, but you're going to be efficient a lot more than maybe some of your old schools, like in a brick and mortar where you go to school for 8 hours a day and then you come home and you have your homework. Instead, you're doing it kind of all at the same time. So that's a great example of technological design. We do it a lot. We do it a ton in science, but we do it in our daily lives. So it's a very important concept, and it's easy to understand because we do it so often. Okay? The result of the design process is a form of technology that addresses the given problem. So typically, we have some kind of a problem that needs to be solved, right? Say, for instance, when you're working on your assignment, there is a problem typically that you're trying to solve. Whether it's a math problem, you're working on a science lab, you're doing some kind of an English paper, whatever that might be, you have a given problem that it's a task, so to speak. And your result is going to basically be some kind of technology that is going to address that problem. Technology can be in so many different forms. It doesn't have to be just your computer. Remember when we talked about all the different forms of technology, it's not just the equipment, okay? It can be a process. It can be something materialistic, but it can be also some other ways that are different forms of technology, okay? A problem can include an unmet need, a desired goal, or an issue that needs to be resolved, okay? Those can all be different problems. So again, your problems can encompass a lot of different things as well, so keep that in mind. Okay, now we did touch on these as well, but this is something that we're going to talk about even in our live class connect, okay? The necessary steps, and I love this picture, and I showed this last week, but this is, look at this long process, this long step to get, a long set of steps to get to the very top. Can you imagine what the view is from there? Okay, so the first thing that we have to do, that we're going to first take our steps up to get there, is you have to identify the need. So if you have some kind of a problem, you got to identify a need, right? What is the need there? What do we need to solve, okay? You're going to do some research then, because typically you cannot solve any problems without research. You can't, if you have no background information, if you don't know kind of, where you've come from to where you want to go, then it's really hard to actually go through that technological design or that process. You're going to start to generate ideas, okay? So you have that need, that purpose, that problem that maybe you're solving. You're going to do some research, and from that research your brain is going to start turning, and you're going to be like, I think I've got some ideas of how we can solve this problem. So you start to generate those ideas, but then you propose a design or several different designs. So you have to figure out, I've got a problem, I'm going to research it, I've got some ideas, but now I've got a design on how to solve those. But maybe I have different designs. Maybe I could do this, maybe I could do that, maybe I could do this. Okay, so you have maybe a couple of different ideas that now you've come up with the design, but now you need to test your designs and see which one is going to be the final design. So when you test them, it's like your experiments. That's part of your, when we think about the scientific method, doesn't this kind of model the scientific method? You have to have your purpose, which is kind of identifying your need. Your research, you're going to find some background information on that. You might generate some ideas, of course, but propose a design and test your designs, that's your experiment portion of it. And you're going to decide on a final design, which could be kind of like your analysis maybe, and then also your conclusion, okay? And then your last thing is presenting a solution. So these are necessary steps. You can't skip one, okay? If you skip one, you might fall on your face, right? Well, hopefully not. But when it comes to this, if you skip something, you're missing a vital part of this process, okay? All right. The last thing we're going to touch on that's in your unit is models. Why it's so important to think about models when we talk about the technological design and that process is that we use models. That can be part of our design and part of, figuring out what's going on and basically coming up with a solution is models. So models anything that represents an object or a system. So we can use models to further study something, to gain a better understanding of something. So it's interesting how much we use models in conjunction with our technological process and design and those steps that you must take in order to come to a solution. So models are used to learn something about a real thing, basically. If the thing is so big that you can't study it, we scale it down. So just like this little guy, he's not that little, but this guy is painting this model of the solar system. We're scaling that solar system down so we can actually see the sizes. We can kind of compare the sizes, we can compare the distances, and so forth, okay? But also, sometimes when something is so small and complex, then we want to scale it up. So here's a DNA molecule or a DNA strand where basically it's so small that we have to scale it up in order to look at it in a little bit, deeper way. So models are really important in this process as well. They really help studying things. I mean, I can't imagine being a science teacher not having some of the models that I use to teach, because they actually allow for so much more understanding. So there you have it. I know, you're probably crying because we're done so quickly, but you can watch this again if you like. No, anyways, there you have it. There's this week's lesson.